All right, guys, one last video on verifying inverses and inverses of power functions. A couple new things, but more just inverse stuff. All right, first of all, review from the other day. Verify that these two are inverses. Remember, in order to do that, you have to fill out or find f of g of x and also g of f of x. I'm going to do f of g of x first. I'm putting function g into f, taking this function, putting in for the x right there. So I'm going 4 times 1/4 x minus 9/4, and I've still got that plus 9 sitting out there. Now, if I distribute that 4, the 4's cancel, gives me x minus 9 inside there, plus 9. And the 9's are obviously going to cancel, so you get x. That should not be a surprise to you at all. G of f of x, do that next, plugging function f into g. So now I'm taking this function and plugging it into that x. So I'm going to have 1/4 of 4x plus 9 minus 9/4. Just work that out. If I distribute the 1/4, I get 1x, the 4's cancel, plus 9/4 minus 9/4, and you won't believe it, I got x. You should always get x both times if they're inverses. If they're not inverses, you won't get x, but this time it says verify that they are, so it does work. All right, find the inverse of each power function. This is the one thing that's a little bit new today. Steps are the same though. Switch your x and y's, interchange those two. Then you got to get the y isolated, so I'm going to divide by 64. And then, because it's y to the 6th, I'm going to take the 6th root of both sides. Now, the 6th root of x is just x. And the cool thing is 64 actually has a 6th root, and it's 2. So there's your inverse. Doing it one more of those. Interchange your x and y. Put the x over here, put the y over there. Divide both sides by 4, which leaves me y to the 4th is x over 4. Take the 4th root of each side. I get the 4th root of x over 4. 4 does not have a 4th root, so you can just stop right there. Okay, the last thing today. Graph f of x equals negative x minus 5. Use the graph to determine whether the inverse is a function. The way you can tell if the inverse of a function is also a function is by doing the horizontal line test, which means you can draw a horizontal line through the graph and only hit the graph one time. So if I draw a horizontal line there or there or there, I'm just hitting my graph, that line, one time. So that means the inverse would be a function. By the way, that's called one-to-one, but all you got to say is yes or no. Is the inverse a function? Yes. One more slide. All right, this one says graph f of x equals 3x squared. Use the graph to determine whether the inverse of f is a function. I went ahead and graphed it on a calculator, which is what we will do in class also. And if you draw a horizontal line through that graph, notice I hit the parabola twice everywhere I draw one, which means it is not a function. Well, sorry, this is a function because it passes the vertical line test. The inverse is not a function because it fails the horizontal line test. So that's how you tell. You don't have to find the inverse to tell. You got to graph your original function, see if it passes the test, the horizontal line test or not. All right, sounds good. See you tomorrow. We'll work on the stuff. It'll be fun.